Good morning, everybody. At least good morning to those of you who are still before midday, and good afternoon to those of you in the rest of the world. My name is Pauline Anderson. I used to be the Chief Examiner for our GCSE Physics. So this is one of the reasons why I'm chosen to present this to you. It's a 1-hour event, so I'm not going to be doing too many activities, apart from the ones which you will see on screen. What we're trying to do today is to look at to give you some feedback. Can't do everything in an hour. To do some feedback on the performance of candidates in June's exam for 1P and 1PR. Chosen not to do 2P and 2PR because I would have needed 2 hours, right? I'm going to have a look at certain questions, the ones that seem to cause problems, and try and see if we can find some ideas of why this performance is less than optimal. We're also going to have, during the screen, we're going to have a look at the examiner's reports. In your pack, you have got the examiner's reports for 1P, 1PR, 2P, and 2PR. You've also got Maths for Scientists, which is a very useful book. I do suggest you look at it if you haven't already done so. You have also the core practical book and one more document if I can't remember what it is exactly. Yeah. So we're going to look at the aims and objectives. We're going to have a start by looking at what is meant by AO1, AO2, and AO3, because without these, your analysis of the exam material is going to be less than detailed. We're going to have a look at AO1, mostly the definitions. Surprisingly, they are poorly done. Extended writing, ways of actually making that better, looking at graphical work, and then just to show it's not all negative, some examples of where we've got students have actually improved. A few screens at the end, which are giving you the support details from Pearson and an opportunity to have any questions. If you've got questions during the time, I will try and answer them. Not necessarily going to type them, but I will try and answer them. Okay. This is our basic thing, we are Pearson. We are Pearson, also known as Edexcel. What you may not realize is we mark over 100 million exams every year. Right, which is and worldwide went into about 70 different countries. Recently, I was in the Middle East, visiting Jordan and Egypt, and we try and get things going around as much as we can. Now that COVID's over, there is a move to get us back out there to speak to you in different parts of the world. Right, I've got one question coming up already. Students will get the formula booklet for the exam again this year in June. Yes. That has been decided upon by the government in the UK, and this exam is taken by some private schools in the UK. So they have to have the same regulations as the rest of the UK on their home GCSE, which means that you get it as well. Okay, so we're going to have a look, first of all, what we're actually looking at during this section. We're going to look at assessment objectives. We're going to have a look at extended writing. We're going to consider calculations, how much maths is in each paper, the analysis and the evaluations part of it, and then using command words. Command words are in, I think, Appendix 8 in your specification. But if not, if you contact Tim, I think it's in the expand. Certainly, it's on the website. How much then? Right. Okay. So assessment objectives, they seem to be a little bit in the middle of the specification, because the specification basically tells you what physics to teach. Assessment objectives are what the chief examiner and the principal examiner use to write the exam paper and to balance the exam paper. They form into three: AO1, AO2, AO3. AO1 is knowledge and understanding. So if it is straight textbook knowledge, right, what is a current? What is voltage? How does a motor work? This is textbook work. There's no application. It is standard. We've got 40% of all the exam papers have to have this. I'm saying 40%, it can go up and down by 1 mark or 2 marks, maybe at the very most. There's another 40%, which is the application and the understanding. So anything which is applied, and the key to saying applied is, do they have to use some information that is given in the start of the question, the stem of the question? If they do, it's application. If it's a calculation, it's application. If it's a graph, it's application. So it's not standard material. So there's 40%. And then 20% is experimental skills, analysis and evaluation of data, and the methods in physics. So we can do analysis of the method and as well as analysis of the data. If you don't say anything to your students about this balance, they might be expecting only AO1. You've probably told them you're getting some practical work, so AO3, but they won't realize that AO2 is just as important. So let's go straight into one of the questions. This was from paper 1P, and it was question 3. So it's the beginning of the paper. We don't expect the demand level of this question to be particularly hard, but we've got, give two differences between the properties of visible light waves and infrared waves. That was the question. The mark scheme underneath said, infrared has longer or higher wavelength. Infrared has a lower frequency. We have this term in the corner, which is reverse argument, allow RA. So if they said it the other way around, if they said visible has got a shorter wavelength, visible has got a higher frequency, that's the same, it's the same two things. So the comment about wavelength, a comment about frequency. We did condone. Condone is a word, is something that we say we're going to allow the mark for this, but we really don't like it, and we reserve the right to change our mind in the future and say no, this is not good enough. If this were at the end of the exam paper, this question at the end of the exam paper, that condone probably wouldn't have been there. We would not have talked about lower energy. All right. Now, on the other side of the screen, you can see the sort of stats that the chief examiner gets to have a look at before he writes his report and before he writes, before he actually goes into awarding and makes a decision. Sometimes it's easy to see the stats. You can see there were 27,000 students did this particular exam. And of those, not 40%, 38% managed to get both marks. And you think, this is recall. This is nothing to do with understanding. This should be standard textbook stuff. So why did they only get 2 marks? Why was only less than 40% getting 2 marks? Why did 16% only give 1 difference? And I think the answer to that one is that they say something like, infrared has a higher wavelength, visible has a lower wavelength. And they've made 2 statements, and they think they've given 2 differences, but in fact, they've both commented about the wavelength. So are two alternatives to the same marking point. So that's a little bit of training. So when you do use a question like this, point out to your students that you've actually this is a training if thing, right? Now, the reverse question, the one that came earlier, which 3B1, was a question about similarities. Give two similarities between them. And in actual fact, it was 65% that got both marks. So maybe it's because there's a lot of similarities and there's a bigger list that they could choose from. But in this case, there were just two differences and they had to get them both to get the mark. Okay, let's have a look, next slide, at what the Chief Examiner had to say. If you haven't read the Chief Examiner's report, it is really good reading. Right? Candidates found this question much harder, and nearly half of all candidates were not awarded any marks. Some candidates were too vague and stated that waves had different frequencies and wavelengths without saying how they were different. These responses were not credited. Weaker candidates got the frequencies and the wavelengths the wrong way round. Right? So I'm giving you this because I think this is a really good example of something that you can do as a revision exercise. Now, I know that paper 1, 1P, paper 1PR, paper 2P, paper 2PR are locked, and they will stay locked until June next year. And they're locked on the website, meaning that your exam officer can go and collect them for you, and you can use them as a mock. But it's a good idea for you to say things like, I know we'll be going to be doing 1P, but let's give them 1PR as their mock exam. Because their papers are very similar. If you actually look at them, they've got very similar content, and they're no more different than a November paper and a June paper are in any case. In which case you can pick and choose the questions that you want to use for your mock. And this one, question 3BI, is something that I think you should be looking at in revision, right? Now, another question, which was AO1, i.e. recall. Or maybe it was a bit of AO2 as well. I'm not really sure. This one was the next question. And it's had a main sequence star is created in a it's giving you a lot of information. It's reminding you it's created in a collapsing region of a nebula. That is content that they should already know. The table gives different energy stores for the gases in the collapsing nebula, from when the nebula starts to collapse to just before the main sequence star is created. Complete the table by placing ticks. Now, students found that you've got loads and loads of well, they found it really hard. They thought chemical, gravitational potential, nuclear, thermal. I think the one that threw them was chemical, and they really didn't understand that. So this is what we got. That was the answer. Chemical stays the same. Gravitational potential decreases because the star is collapsing in. Nuclear stays the same because you haven't yet got that fusion, but the thermal increases because of the pressure, right? And we gave 1 mark for each row. Look at the distribution, right? Of our 27 and a bit thousand people, right? Less than 7% got all 4 marks. And you've got this lovely little distribution in the middle here. And this is these two at the bottom are typical examples. Chemical was common. Most of them got common. Quite a few of them got gravitational potential, but they really didn't know what to do with thermal or nuclear, right? So that's again, it's it was harder than we expected. Right, okay. This is what Chief Examiner David Whiting had to say. Candidates found the question very challenging and had not, perhaps, previously considered the energy transfers during star formation. Most candidates correctly identified that the thermal store would increase and that the gravitational store would decrease. Confusion arose with what happens to the nuclear and chemical stores, which suggested that candidates struggled to differentiate between chemical and nuclear reactions. It was expected that candidates knew that nuclear fusion does not happen in protostars, but this was only linked to the nuclear energy store, saying the same for the most able students. Right? So a very demanding question quite early on. What he said here about the differentiation between chemical and nuclear reactions was actually backed up. I chose not to have a look at question 1, no, is it question 2? There were some multiple choice questions about one which was talking about an ion. They gave the uranium and said it had, and asked about the ion formation, and again, very poorly answered. Okay. I'm just reading from Francis. Ask about A2. Sort of teaching needed for what is information and diagrams. Right, we do modular exams. Astrophysics is studied for the final module in A2. But you're talking about the first module. Right, okay. So what I'm talking about now is the last paper. The UK cannot have anything. We cannot have modular exams. Modular exams are only for overseas students, international students, and the first exam is not until next summer. All right. So, yes. So this topic will be in A2 next year. It will be in the second module or the second exam paper, whereas in the UK, or if you continue doing linear, the modules will be, the topics will be rearranged in any order. Okay. So you are actually quite lucky. In A-level has the same thing. The international A-level is modular. The home one is not. Okay. Right, another assessment objective 1 question. Right. Okay, less than a quarter of all candidates knew the correct definition of the term voltage. And you think, oh, why? What is meant? And I think, to be honest, after looking at this, this is what we allowed. We wanted energy per unit charge. Now, the brackets bit in the mark scheme, when it's in brackets, it means I don't need to see that word. So if I have energy per unit charge, that's enough. The semicolon at the end of it means 1 mark. We allowed the equation only if they defined the terms, right? We did allow work done for energy transferred, and we allowed Coulomb instead of unit charge. So if they said energy charge, energy per Coulomb, we accepted it. So less than a quarter knew that definition. Is this only something that you teach in year 7 or 8 or 9, and maybe they're not taught by a physicist, right? And they've got this idea that it's I don't know, maybe that's the reason why they don't do it, but I would have thought that the settling down questions, when people come into a classroom or your lab at the beginning of the lesson, I always have a to do now, and I usually give them maybe at most 3 short questions, and I make them write them on a whiteboard, on a small whiteboard, and they have to write their answers, and then when they've written the answers, they've got to hover it. so that nobody near them can see their screen. I can see they're ready because they're holding the whiteboard up like this. And when I say, look, I can see their answers on that whiteboard, right? Sometimes I have to make them do that because they've written them the wrong way around. But this is one of the things that I would tend to do to make sure that they are totally familiar with this. And guess what? Here are some of the answers they gave, right? Okay, I agree with you, Francis. People are incredibly lazy, right? Do mini tests, crosswords, etc. Agreed. But the do now question at the beginning is also very good for settling them down. The difference in energy transfer between 2 points on a circuit or across a component. Have they mentioned unit charge? And the answer to that is no. So that first one will not get the mark. Energy per coulomb, nice and brief, does get the mark. The potential difference across the circuit, that first sentence doesn't get the mark. Energy per unit charge does get the mark. So in the bottom example, the fact that they've written potential difference across the circuits is ignored. We don't mark negatively, except if they do direct contradiction. Okay. So assessment objective 1. Recall, make sure they know the stuff, right? An example of, for example, a motor, and you think, how are they going to make sure they get the motor right? You can give them the stages in the motor, and you give them to them in a jumbled up order and make them do it put them in the right order. A simple exercise that they can do. And again, it's a settling down thing. You can put them on the screen and have 1, 2, 3, 4, 5 statements maybe in the wrong order and say, right, put them in the right order and just give them numbers. It's, yes. Is the session recorded? Yes, it is. And you get the PowerPoint as well for this. I did do a session which was on modular, which was mostly modular recently, an event, so maybe you missed that. Yet another definition that they didn't know, right? Half-life. And it's fairly straightforward. Time taken for the activity to halve. They want to use all sorts of different things. So they want to use, they say nuclei, we want nuclei, we want atoms, we want isotope, we want mass, half of the radioactive mass to decay. We're going to ignore substance. Substance comes up maybe because of a link from chemistry. We're going to allow count rate instead of activity. We're going to allow, if you like, common English like how long it takes rather than the time taken. We are going to reject, and you don't often see it, reject half the time. So this is a 2-mark question. So when we say reject half the time, it's rejecting for that first mark only. So let's have a look at these. Can they get the rest of this? The time taken by radioactive isotope. So, okay, we've got time taken to become half of its original value of what? Right? They've got the half, even spelt it correct. But we haven't said, okay, half of the activity, half of the isotope to decay. It's not quite enough, just gets 1 mark. How long an object stays radioactive as its radioactivity gets divided in half? How long it takes for the radioactivity to decrease? Again, it's a 1 mark. Radioactivity gets divided in half. I'm sorry, it's just not precise enough. And the third one, half-life, is how long iodine will be radioactive before it decays. The number of atoms will increase as the half-life increases. Some very odd ideas there. Again, this is possibly due to somebody talking about decay chains. And students have picked up an idea, half picked up, if you like, a more demanding idea. Okay, let's go on. I'm rushing because I know I've got this. This is what the examiner said. Standard definition. The most economical version is the time taken for the activity to halve. So please get your students to learn that definition. All right. There's two examples. The first one is at the top here is the nucleus, because it's a nucleus and not nuclei. It's got to be more than one atom. Half the amount of radioactive substance was insufficient. We're not having radioactive substance. It might be okay in chemistry, I can't confirm, but it's not good enough in physics. Right, our next section. Again, I'm looking at paper 1P and 1PR, but this one was a nice one in 1P. A red star becomes a white dwarf. Discuss the differences. If you look at this, you've got a really, really lovely distribution of marks. Some of the content is A or 2, but some of them is A or 1. So let's have a look. That was a mark scheme, right? So we have got 6 marking points. Now, this is a big difference between international GCSE and international A-level. When you go into the A-level, you won't get as many where you've got any 4 from. You've got to get these 4, right? We've got RA again for marking points. We had ideas about brightness. We had absolute magnitude, luminosity, power. The simplest one is the red giant emits more light. It's a bit iffy, but probably correct. What about nuclear fusion? We've checked this very carefully. There is some evidence the white dwarf has got some nuclear fusion in the outer layers, but certainly not in the core. We've got size, we've got temperature, we've got density, and we've got planetary nebula, right? So all of those are the mark scheme. Right, okay, let's have a look. Red giant is unstable. It's expanding as it's running out of hydrogen. As it's red, it shows it's not very hot. However, it's quite bright. It's compared to, again, however, it's quite bright compared to a white dwarf, which is very dim. That is just one marking point, not 2, but it's very hot. White dwarfs are also far more stable than a red giant. Okay, and a couple more here. Right, I'm aware of the time, so I'm going to flick through. This one got 2 marking points. Right. It's got its brightness and the temperature. I didn't do the bottom one here. I don't know why. Maybe I didn't save it properly. Right, 2 marks there. Right, fusion still happens in a red giant until all hydrogen is used up. Surface temperature decreases, the core temperature increases, and eject gas and dust, which becomes a white dwarf. Now, I think in this one, if I'm going back, discuss the differences. Discuss the differences. So what has this student done? Right? They've not done differences. They've given you last year's question, or a question that they've done in revision, which was talk about the life cycle. and they've actually done the evolution. So they're not actually following what the question asks, right? This is what David said. The question differentiated well between candidates. Most candidates achieve 2 with a normal distribution. Marking points 3 and 4 more commonly awarded, with marking points 1 and 2 often seen in many responses. However, it was evident that there were some misunderstandings as to the differences between the two stars. Many candidates who were unsure simply stated that white dwarfs are red. White dwarfs are white. I'll start again. Many candidates who were unsure simply stated that white dwarfs are white and red giants are red, which scored 0 marks. And so you've got an example there, and he's given a mention that where they've got the marks, and this was a standard sort of question that we ended up getting time and time again. Okay, so in that case, in this particular case, we had students who were not following the command word. Now, when we give a question, we do always give a command word, a single command word. This one is explain. When it says explain, we need a logical sequence. We don't need a description, we need a logical sequence. Right, when you read this question, explain how the magnitude of the acceleration of the object changes from the instant the object is released until the first time the object returns to its initial resting position. You should refer to the forces acting on the object in your answer. So we've given you a lot of scaffolding. So this makes the question, they've never seen this. This is about a spring which is pulled down and released, right? So it's going back upwards. We've given you a command word. We've given you magnitude. So we're not talking about the direction of the acceleration. We're talking about the size. We've given you the start point from the instant the object is released until the first time it returns to initial things. And we're telling you, you should refer to forces, right? So we're giving the student a lot of information to deal with, and maybe it's a good idea that they actually are reaching across, so they use one of these, a highlight pen. In this particular case, this is a highlight pen which is a softer pastel color, right? And it's also erasable, so you can actually remove it, but it means that you can still see the writing underneath the highlights. So we get, this is a mark scheme. The first mark was acceleration decreases to 0, right? And then 2 of these. Okay, so we're looking at the magnitude will change. Well, if they're writing the word change, we are not going to give them a mark, because we're not saying, we're telling them, is it going up? Is it going down? Is it getting bigger? Is it getting smaller? Right? Then the students go on to talk about kinetic energy. There is 0 marks for energy, right? And the transfer elastically once it returns to the resting point. So this particular student has got 0. And they probably came out of the exam and thought they'd done well because they could answer the question. Or so they thought. So they're not using the scaffolding, right? Now, and the next example, magnitude decreases. Okay, so that gives us one idea, magnitude decreases. We'll take the term acceleration as read because the question asks you, talk about the magnitude of the acceleration. So if they say the magnitude decreases, that's a mark. As energy in the decreases due to air resistance. So the spring has less elastic potential energy. And then there's a mark for the weight stays the same. That was surprisingly uncommon. And the upward resultant force of the magnitude decreases. That actually was given 3 marks. Decreases, again, we're linking it to what the last question asks about, which is the acceleration. Right, again, weight remains constant. The upward force decreases due to air resistance. We ignore all the rest of this, right? So these are examples of how students don't use all the scaffolding that we give them. And the examiner's report, it said, the question offered a challenging opportunity for candidates to demonstrate their knowledge and understanding of forces and how they link to changes in motion. Many candidates failed to read the question properly. They effectively explained what had happened in the whole acceleration, not what was asked for. Other candidates gave well-rehearsed explanations of terminal velocity, which were also irrelevant. More able candidates were awarded a mark for recognising the acceleration would decrease, while the most able would link this to the forces. And there's an example where you've got 2 marks. Our next area I want to look at is graphical work. There is evidence that students actually are getting better at plotting. In this case, the plots were there and they had to draw a line through them. Right? We ignored the extrapolation. They had to calculate the component. Now there's 5 marks. Calculate the resistance of component X when the voltage is 4.2. So they had to read the scale, which is quite an easy scale, take the reading off there, substitute it into the correct equation, rearrange it. This is in milliamps, so at some point we're going to have it with conversion. And there were 5 marks for this, getting a matching unit, right? That was a bit that most people didn't do wrong. But we also did find this, right? Now, in biology, because they are often using discrete data, dot to dot is okay. Now, this is where I really do think you should have a look at the Maths for Scientists book, if you haven't already looked at it. There's a good section in there on how to, on maths and drawing graphs and so on, but this is not acceptable. This one was from 1PR, and they had to generate their own data. They were given that first point and they had to work out the half-life. That was a question on iodine. But they ended up doing this. And in terms of physics, you know, a graph that curves up again is very unusual. So engage brain, make sure that your students are aware that, I mean, that was such an easy mark, right? The thing to use as well is a clear or translucent ruler. If they have a translucent ruler rather than a wooden one, then you are actually going to be able to shove it up and down and see and get a decent line. Right, that particular student who did that first grotty line went on to do this, and that's all they gave, right? And as you can see, they went on, and it was awful. The examiner said, although this candidate has not drawn a straight line on best fit, they read the current in milliamps. The calculation is complete, but there's a power of 10 error because they haven't converted milliamps to amps. Only ohms or multiple of ohms were acceptable, i.e. kiloohms and so on. Voltage per milliamp is a reasonable guess, but it's not going to get the mark for standard SI units. This was the distribution. So there is evidence of this question that people were getting a good mark, but there is room to improve, because nearly 40% got 5, and something like 20% got 4. So there's a common thing, as I just mentioned, getting the unit right, making sure there's no milliamps, and you've not converted it, and making sure your line of best fit is good. Right? Similar graph question. Now, this was right at the end of the first paper, 1P paper. Sorry, I've just noticed I put P with a small p. They were given this question where they're given a graph, and they had to actually, they're told, by drawing a tangent to the curve, determine the acceleration, and then determine. When you see the word determine, it means you've got to do some calculations probably, but we're not telling you how, and it may not be a traditional calculation. We found that a number of them could not get that tangent. They do tangents in maths. So why are they not transferring that skill into physics? Maybe because we've never demanded it. So we actually gave them a range. If it was easier for us to see that they got a reasonable tangent if they could get into this range. If they could get their answer between 1.05 to 1.15, they got 4 marks. If they weren't quite as accurate, they got 3 marks. Determining the distance travelled under the line. If we could see a method, we would give them number 2. We'd give them marking, right? Okay, I'll read that in a moment, Francis. So we're giving a mark. We also gave them now. This does occur in the spec, but it also occurs in pressure, because one of the suggested examples is always make your students stand on 1 foot and draw around it and work out the pressure beneath them, etc., etc. And they've got to calculate. So as a similar method of doing this, a lot of students we found, okay, just go to this, they found the graph very challenging. It was at the end of the paper, so it was expected, but they simply read off the velocity and time from the point and substituted them into an acceleration equation, because they didn't do an increase. They didn't do delta velocity or anything else. So these are the comments. The one thing that students did was they tried to use v squared equals u squared plus 2as. But it's invalid for non-constant acceleration. Right, okay. No, there was no read-off, no requirement to draw the read-off. When I marked for CIE as well, Francis, so we expected that to do that, and we worked out the answer. If they've got that answer, if they've got 1.1, they can only get 1.1 by doing the work. And hence we can look at the answer and say their graph, their tangent must be appropriate. They've obviously used the right equation, and they're accurate enough to get it into the right range, so they get the full marks. It's a difference in the way that we mark. I marked the paper, but the point of this question was not looking at the read-off. There's another place where they might have had a read-off. But we only test each skill once, or we tried to only test each skill once. Now, we did get a few questions which were really well done. Right, I'm looking at the next thing. Students need to learn gradients using tangent more. Right, I do say yes, I agree. How do marks distributed on the graph drawing? I can't remember on that one. Oh, this one, sorry, this one here on this. It was very, very poor. I think we had almost nobody got full marks across the whole, because that was 4 and that was 5. So that's a total of 9 marks. I think less than 10% got all 9 marks. And there were a large number of people who got almost or got 1 or 2 marks. And some people got a mark because they said that distance equals area under a line, or they showed that they tried to block it into rectangles and triangles, or they showed a method. So there were some at about 3-4 marks, but very few got the full marks. As I say, less than 10%. So that was a comment. So let's go on to what they did. This was an interesting question on 1P, and there was a similar question on 1PR. And it showed a light source, and it said the refractive index of water is this. Explain the paths of the 2 rays of light after they strike the boundary between air. Include calculations. So they were given at the moment, I can't actually remember off the top of my head. The bending of the wooden strip wasn't too bad. Otherwise, I would have pulled it out as being particularly an area. Having marked it in the summer, it wasn't too bad at all. Students didn't. The thing they didn't know how to do was to measure from that ruler at that point and measure the bend. They didn't realise they could measure up from the floor. Up to that point and up to the floor from when it was bent. So that was the section that they found hardest. Some of them obviously got the which variable is which wrong. They got the independent and the dependent the wrong way around. To be honest, I'm marking A level at the moment and they're still doing it the wrong way around. Will the students, the modular will have the modular. Can you put that question, Cindy? Can you put that question? I'll give you a slide at the end to Tim, because he will be able to answer that. The modular is still being written at the moment. If this had been in a fortnight's time, because I'm talking to the chair of modular, I could have answered, but I won't know. Science is practical in the single award. Not sure what you mean, Tazim there, or Fatima. Okay. So this one, they got that at the beginning. They got lots of space and they got a full page to write, and we were really quite pleased with this, because when I looked at the marks on this one, that's what we got. Right? It was a really, as you can see, it really discriminated extremely well. Right? If you actually look down and you actually look at this and you say, well, that's 20% and that's well over 15, so over a third got 5 or 6 marks, and then probably another third got 3 or 4. Right? Some of the candidates thought that B would undergo total internal reflection, and they showed a reflected. The calculations were tended to be done well, but candidates also calculated critical angle, which wasn't required. They didn't read the instructions again carefully. They didn't include, they understood the purpose of the word explain. And they didn't include the reason. So where they didn't get the 6 marks was they did the diagrams, and that was fine. We got the marks for that. They did the calculations, but they didn't include the reasons. All right. Again, Hilda, I can't answer that at the moment. Again, it's something that Tim Lawrence will be able to answer. He will not know himself, but he will know who to ask. and he will always respond. Because if he doesn't respond, there's a system where he's got to respond in a certain length of time. Right. I didn't include them because they're quite large slides, but there are two clear examples in the examiner's report for this, beautifully organised. This one was from 1PR. This is a practical example. Okay, so they were told they had to determine the density of some small rocks, and the question there is describe a method, right? So this is not an explanation. This is a description. You do A, then you do B, then you do C. We don't require them to write in full sentences. They can write in bullet points. They can write a lot of information. If they want to, they can do it as a flow diagram, right? But the thing is, it's got to be legible. Now, this one, right, had a total of 11 marking points, right? And we did notice that overall, we have an improvement, right? We've got decent diagrams, right? We've got labels, okay? So displacement can, it's going to go, I'm going to ignore wavy water, choppy water, as though it's in the middle of the sea, right? But a displacement can, we've got a measuring cylinder, we've got the rock, it's clearly tied. On the other hand, we've got a clear indication of the volume of the rock. It's a pity that is not labelled, because that was a top hand balance. But you can see they are mentioning the correct measuring instruments. They are telling you how to work out the relevant quantities, the volume. They are mostly putting labels on. All of these are to be praised and say, yes, please do it. We're not art. I don't care if you're doing it. I mean, this is hand drawn, right? I don't care. I can make it out. It's just a pity they didn't put that top hand balance label on. But this was a typical sort of question that we got. Right, so I'm up to 6 minutes before the hour. So I'm just going to give you what the chief examiner said. These are the things to say. Put this up. Put this up in your lab or your classroom, right? These are the things that they should know about. They should take advantage of opportunities to draw label diagrams instead of written answers. Know the SI units, be able to use the formulas, take note of the command word, take note of the number of marks and use as a guide. We're not marking English. If the spelling is sufficiently correct, we will mark it, except fission and fusion. Right? Francis, if you are that very helpful and very nasty in your lesson, then you will have trained your students extremely well. Right? Sometimes we're a bit softer, but don't tell them that. Don't tell them that we're going to accept Beaker. Right? We don't usually. But I've accepted Beaker with a spout. Right? This was the 1PR exams comments. Take care when drawing diagrams. Ensure that they can see. Note the number of marks. Note the command word. Be familiar with the equations. Structure multi-step calculations as simply as possible. Didn't really have the time to do much about that, but the answer, if we see the answer on the answer line, we will give the marks. If it's not right, we will go to the top of the question and mark down. If they put the numbers, a dimensionally correct substitution into the equation, so they put an amp, even if it is milliamps, or whatever, into the equation correctly, we will give that mark. If they rearrange it incorrectly, that's the point at which we stop. So if they do a rearrangement first and it's incorrect, we won't mark the rest of them. right? With the displacement can, you first of all put it on the side of the bench. You fill it until and you capture everything that comes out. Then you start your experiment. So that's when you know it's full, right? But you don't count that, or you throw the excess water away and then start again. So what can we do? Okay, they gave me some space here, so I put a couple of nice astronomy pictures in from NASA, right? So no copyright issues, they're all from NASA. I would say to your students, don't do your revision from the beginning of the course. Pick a topic and do that revision. Then the next time, do another topic. I had students who used to say, well, I started at page 1 and I got to page 4. And then the next day I said, well, where did you start? And they said, page 1. And where did you get to? Page 6. I said, so pages 1, 2, 3, and 4 have done really well. They've had 2 goes of, oh. So they need to make sure that they're planning the revision and do the different topics at different times. Make sure they know the definitions. Don't be vague. Say it increases rather than it changes, or it decreases. Read the question, read the question, read the question. Use the scaffolding, draw diagrams. And as teachers, and I'm going to say this really importantly, teach the specification in the order that suits you and your students. When I was in Egypt and I spoke to some teachers there and I said, what do you teach during Ramadan? And the answer is the students are going to be affected by Ramadan. So are you going to teach a really difficult conceptual topic at that point, even if that's what it seems that you should be teaching? No, the answer is no. Do it. Choose the order of teaching to suit you. Use practical simulations, demonstrations as often as possible. There is a company called Focus Educational. They do simulations. It's something you have to buy, but it is, I believe, £100 UK for all the students in your school and all the staff in your school for a full year, and they can use them at home. And they have simulations of loads of our practicals. Use all of the papers to write your mocks. Read the examiner's reports. I've given them to you. Use Results Plus. I know some places have some issues, but we are working on trying to get that issues. Emphasize command words. Emphasize scaffolding. And please, talk to your maths and chemistry department. If you're teaching them one thing and they're teaching them 2 weeks later in a different method, the kids are going to get cognitive conflict, right? Oh, Francis, no, we're not going to, no, I don't think that one. And I can say that site again. I think I can type into this. Focus Educational, if you have looking for that one, a website. I do know that they will give you a 14-day free trial if you want to have a look at it for simulations. I've used them for over 20 years. I used to be able to actually leave my kids in the computer room with for example, a year 9 doing an electromagnets, and they put coils and they dip it into a bowl of nails all on the screen, and I make them do the results on a spreadsheet, make them do the graph work, etc. I know that they would actually get on and do it, and I like them because they come with random errors. So on 10 o'clock, going to click. This is the guy that you want to speak to. Any questions, go to Tim Lawrence. Right, very nice. You will always get a code number coming back saying this is your thing. He's the guy to speak to. He may not know the answers, but he will know who to contact. right? And then again, this is Results Plus, really useful if you can get it. And we are working on making sure everybody overseas can get it as well. Is Dr. Irene available? Yes, you can also email her, but she tends to do A-level more, right? Tim tends to do the IGCSE and Irene tends to do the A-level. And I think so. Okay, 1 minute past 10, and it's been lovely to chat to you, talk at you. I hope you've actually found some of it useful. As I say, come back via Tim or Irene if you need to. Some of you, I'm doing an A-level 1 in 2 days' time. So I may speak to you again on, I think it's Wednesday. I think it's Wednesday. Could be Thursday. Yeah, Thursday. Sorry, not Wednesday, Thursday. Yes. All right, it's Tuesday today. So I think it's Thursday I'm doing this for the A-level 1 feedback. Okay. The A-level modular, yes, there is module 2 of the second topic for the A-level modular, because when I came back from keep a lookout for that because it's got to be rescheduled. I should have done it last week. Unfortunately, I had a complete meltdown of my laptop. It would not talk to any of the rest of my equipment. I could not open, I couldn't open Facebook, couldn't open Zoom, couldn't open Teams, couldn't open anything. And I am now considerably poorer because I had to go into the Apple Store and buy myself a brand new Mac. And would you believe it? I had to return it the following day because the first Mac they gave me had issues as well, and it wouldn't even open the App Store on the Mac. So I'm touching wood that I actually have got it there. So there is the A-level, there's a 2-hour session coming up at some point to be discovered, and that's more in depth. This one is a quick one on Thursday for A-level feedback from the summer. Hopefully you will get all of that feedback and all of that information. You've got the presentation, you've got the examiner's reports, please read them. You've got the other documents that you can have a look at as well. Use the maths book because it's so essential. If your chemistry department aren't aware of it, they often the people who do cross multiplication in their equations and so on, make sure they are aware how to use the maths for scientists. Having said that, thank you. The